Hello everyone, welcome back. In this video, we are going to learn class 10th real number chapter exercise 1.4 question number 1. Now let's read the question. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. So here we have the first question, that is 13 by 3125. So here now we have to find what the numbers are terminating or non-terminating. So here first let's do the first question. So here let's do the prime factorization of q. Here it is in the form this number is of form p by q and q is here 3125. So I am doing the prime factorization of 3125. Okay, now here I am doing 3125. Now this 3125 is divisible by 5 and here 625, and again this 625 is divisible by 5, that is 125, and again 125 is divisible by 5, that is 25, and again 25 is divisible by 5, and here 5 and here 5 and 1. So here this 3125 can be written as 5 root 5. Okay, now how to say that this is a terminating number or a non-terminating number? And please see the previous video on the theorem 1.5, 1.6 and 1.7 for the better understanding. So in the theorem says that if we have a 2n into 5m, and if we have this form, then it is a terminating number. So here you can see that it should be, now here we have 5 raised to 5. So it is in the form 5 raised to m. So this we can say that it is a terminating number. Now even if we have 2 raised to 2, then it is also terminating. So we can say anything, any number which is in the form p by q, and when we do the q factorization, it should be of 2n into 5m. Then it is called a terminating number. Now let's see the question number 2. And now the question number 2, that is 17 by 8. Now this is in the form p by q. Now let's do the prime factorization of q, that is 8. So here 8. Now 8 is divisible by 2, that is 4 and 2, and again here 2 and 2 ones is 2. So here this 8 can be written as 2 root 2. Okay, now I told you that it should this q, when we do the prime factorization of q, it should be of form 2n into 5m. So here you can see that this 2 root 2 is of form 2 root n. So we can say that 7 by 8 is a terminating number. Okay, I think you are understanding the sums. So here we have the third question, that is 64 divided by 455. Now this number is also in the form p by q, and q here, let's see the prime factorization of q. So here q is 455. Now let's do the prime factorization of 455. So this 455 is divisible by 5, and here 91. So this 91 is divisible by 7, that is we get 13, and 13 ones is 13. So here this prime factorization of 455, we can write it as 5 into 7 into 13. Now in this question you can see that if to find this number is terminating or not, if it is terminating, it should be of 2 in the form 2n into 5m. But here in this question you can see that we don't have a terminating number, but we have you can see that we have 5, but here 5m, it should be of 5m. So here you can see that it is not in this form. So here this question is non-terminating. Yeah. So here we have the fourth question, that is 15 by 1600. So here this number is also in the form p by q, and here let's find the prime factorization of q, that is 1600. So here I am doing 1600 is divisible by 2, we get 800. Again 800 is divisible by 400 is again divisible by 2. So here we get 200, and even 200 is divisible by 2, we get 100. Again 100 is divisible by 2, that is 50, and again 50 is divisible by 2, that is 25. 25 is divisible by 5, and here 5 and 5 and 1. So here this 1600 can be written as, that is 2 root 6 into 5. So here this q is of form 2n into 5m. So this is a terminating number. And here we have the fifth sub question, that is 29 divided by 343. Okay, now let's do the prime factorization of 343. So here this 343 is divisible by 7, that is 49. Again 7 is divisible by 49 is divisible by 7. So here 7 and 1. So here 343 can be written as 7 root 3. Now this 7 root 3 is not in the form 2n into 5m. So this is a non-terminating number. So here we have the sixth question, that is 23 by 2 root 3 then 5 root 2. Now you can see that this decimal expansion, they have done the prime factorization of the denominator, and the decimal expansion is 2 root 3 and 5 root 2. Now this is in the form 2n into 5m. So we can directly say that it is a terminating number. So here we have the seventh sub question, that is 129 by 2 root 2, 5 root 7 and 7 root 5. So here let's do the prime factorization of 129. So here when we do the prime factorization, we get 43 into 3. Okay. So here you can see that we have the denominator in the decimal expansion form. So I write it down same as it is there. So here you can see that it is in the form 2 root 2, 5 root 7 and 7 root 5. So here it should be of the form 2n into 5m. So here you can see that it is in the form 2n into 5m. But you can see that it not only these two, you have 7 root 5. So here we have an extra number. So it is in the form non-terminating. So we can say that this is non-terminating number. So if the number should be terminating, then it should be of the form 2n into 5m. Then it should not have any extra number. Okay. So here we have the eighth question, that is 6 by 15. So this 6, when we do the prime factorization of 6, that is 3 2s is 6 or 2 3s are 6. It is in the same way, and 3 5s is 15. Okay. Now you can cancel these 3 and 3. We have 2 by 5. So this is terminating or non-terminating. So you can see that 5, it is of the form 2n into 5m. Okay. So here only if it should have only 5 or only 2, or it should be in this form, then we can call a number terminating. So here we can call this number terminating because it has 5. So this is a terminating number. Okay. And so here we have the ninth question, that is 35 by 50. Now let's do the prime factorization of this. So here 35 can be written as 7 5 is 35. So now let's do the prime factorization of 50 here. So here 50 is divisible by 2, that is 25. Again 25 is divisible by 5, that is 5. And 5 ones is 5. So this 50 can be written as 2 into 5 into 5. Now I'll cancel this 5 and here 5, that becomes 7 by 2 into 5. So you can see that this 2 into 5 is in the form 2n into 5m. Okay. So here we can conclude that this number is a terminating number. So here we have the 10th question, that is 77 by 210. Now let's do the prime factorization. Now this 77 can be written as 7 into 11. Now let's do the prime factorization of 210 here. So 210 is divisible by 2 and we get 105. Now this 105 again is divisible by 3. So we get 35. Then this 35 is divisible by 5 and here that is 7 and 7 ones is 7. So this 210 can be written as 2 into 3 into 5 into 7. So I'll cancel this 7. So I'll cancel this 7. So here you can see that this number is not in the form 2n into 5m. So we can conclude that this is a non-terminating number. So this was the last question. So we have completed the exercise 1.1 question number 1. Now if you like this video, please subscribe and like our channel. Thank you.